Today we're going to talk about percent change, and you should already have the lesson 2.7% change guided notes in front of you. Okay, let's begin. So we're going to start with a warm-up. So you have the problems in front of you. I want you to go ahead and pause the video and then give these problems a go. Okay, so now you should be done. So let me go over how to do this. So first thing I would do is I would distribute this negative here. So I'm going to fish for this one and fish for this one. So I have 8t minus 4, and that's a negative 1 times the negative t, so that's a positive t equals 7 plus 2t. So then I'm going to combine like terms. 8t plus t equals 9t minus 4. All right, so now I really need to get everything kind of on the same side. So what I'm going to do over here is I'm going to add, I'm going to get rid of the 2t over here, so minus 2t. And when I minus 2t, that's going to give me 7t minus 4 equals 7. I'm going to move that up here so we have room. So let me write that again. 7t minus 4 equals 7. Now I need to get the 4 on both sides. So that's 7t equals 7 plus 4. So that's 11. And now I need to get the t by itself. So I'm going to divide by that. And I have t equals 11 sevenths. And that's good enough, or 1 4/7. So then over here, I'm going to do my cross multiply butterfly action. So I'm going to say it's 5 times x minus 1 equals 13 times 9. So I'm going to distribute this 5 to both. So that's 5x minus 5 equals 9 times 13, ooh, I'm going to have to do that one over here. So that's 7 to 11. So that's 117. Now I'm going to need to add 5 to both sides. So that's 5x equals, let's see, 122. So going over here, 5x equals 122. I'm going to divide both sides by 5, and I'm left with x equals 1/22 over 5, which is really ugly. So I'm just going to leave it like that because it doesn't actually reduce anymore. If you did want to take the time, you could put it as a proper fraction and say that it's 24 and 2/5, but honestly, I would just leave it as 122 over 5 and call it good. Okay, so that's our warm-up. All right, so I wanted to do a problem to kind of explain what percent change means. So Dwight got a 17% salary increase when he got promoted to assistant regional manager in his mind, or assistant to the regional manager. So really, what does this mean when I see a problem like this? Like, what do these words even mean? So what this means is the new salary is equal to the old salary plus 17% of the old salary. Right? And of is that magical word for like times. It's that hidden code word, right? So we have the new salary is the old salary plus 17% of the old salary. Now that we know what that means, let's talk more about how we do percent change problems. I think the key part in whenever we have difficult story problems is just trying to figure out what they mean. So let's look at this. Gwen is a lab technician in a hospital. When she first started, she made 32 per hour. Now she makes 40 per hour. Determine whether the percent of change is a percent increase or a percent decrease, and then find the percent change. Whew. So we need some sort of process for this. So here's the overall process for how we're going to do percent change problems. When we're going to do a percent change problems, we're going to ask ourselves, is the value increasing or is it decreasing? So that's really the first step. So she started at 32 an hour, and now she makes 40 an hour. So I would say, okay, she went from 32 to 40. That's an increase to me. So increase, pretty nice there. Using, so then it says write a ratio using the original number as the denominator and the new changed number as the numerator. So I just like to think of it as change over original. Okay, so that's what we're going to do for that one. And then it says set the ratio equal to 1 over 100, then solve. So what I'm really saying is, look, I want you to write, and I'll write this a little bit better, change over original equals x over 100. So that's how you're going to set this up. And then you're going to write your answer as x% increase or x% decrease. So let's take a look at Gwen over here. So find the percent change. So we know that she went from 32 to 40, right? So the amount changed is 8, right? The difference between that is 8. And we're not concerned that it's a positive 8 or a negative 8. We're just going to say the amount change is 8 because we're going to define that when we talk about increasing or decreasing salary. So we have 8. So I'm going to put the change on top and say that's 8 over 32, which was the original amount. So the change is on top. So maybe you just want to think of this as better as just like change. What's the change? That might be a better way to express that. 8 over 32. And then we set that equal to x over 100. Now this is a problem you know how to do. I'm going to simplify this first because I see 32 and I see 8 and I think, oh my gosh, I can simplify that. And that'll make my math easier. So I'm going to say 1/4 equals x over 100. Okay, so crisscross butterfly, I get 4x equals 100. So divide both by 4. X equals 25. So then I need to answer the question, and I would say she has a 25% increase. Okay, so that's what we do. So for this one, it doesn't matter if I do 40 minus 32. I don't care if it's positive or negative. I just want to know what was the percentage that changed. So the percent that changed was 8%. My original, or the amount, I'm sorry, the amount of money that changed was $8. Like she got an increase of $8. So I put the increase or the change over the amount she started with. And then x equals x over 100. This is how you do the percent change problems. So we're going to do another example before I have you try these on your own. So here's the other example. Determine whether the percent of change is a percent increase or percent decrease, then find the percent change. So original amount of money that someone made was like 20 and the new one is 4. That to me, we went from 20 to 4. That's a decrease. And again, maybe it's not dollars, maybe it's something else. Because that would be sad. We'd be very sad about that. So maybe it's like discount. Like originally this cost 20, but now it costs 4. That sounds better. So we saw a percent decrease. So we want to find the percent change. So to find the percent change, first I need to find the change. So the difference between 20 and 4 is 16. Okay, and I just went 20 minus 4 to find that. Again, I'm not concerned with the positive or negative because I'm going to be talking about it being decreased. So I'm going to say, okay, my change is 16 over my original, which was 20, equals x over 100. Crisscross. Well, actually, before I crisscross, I'm going to look at these and see, wow, these are both divisible by 4. So I'm going to simplify and say that's 4 divided by 5 equals x over 100. Again, to make my life easier with the maths. So now I'm going to crisscross and say that's 400, because 4 times 100 equals 5x. All right, so I'm going to divide both sides by 5. And if I do that, well, that goes away. Maybe I'll just look at 40 divided by 5. I know that 40 divided by 5 is 8, so x must equal 80. So then I would say, okay, there's an 80% decrease. And there I go. There's my answer. Okay, for this one, I want you to try these with the people next to you. So however we've done that in class, the people that you go over problems with next to you. So you're going to determine whether the percent of change is a percent increase or a percent decrease and find the percent change. So go ahead and pause the video to work with these with your neighbor friend. And then when everybody's ready, we can come back. Okay, now we're ready to come back. So what we have here is my original was 20, my new is 18. So I went from 20 to 18. That to me is a decrease. And my change is 2. So I'm going to say it's 2 over 20 equals x over 100. Okay, now what I'm going to do is reduce this because, again, life is easier. So I saw that I could divide both of these by 2. So I divided both by 2. 2 by 2 and 20 by 2. And I got 1 over 10. So now I'm going to cross multiply. And I get 10x equals 100. Well, that's nice. Divide them both by 10. X equals 10. So I saw a 10% decrease. 10% decrease. Okay, looking at the next one, I went from 12 to 48. That looks like an increase to me. And the change, let's see, 48 minus 12, that is going to be 36. So the change goes on top, 36 over my original 12 equals x over 100. So in this case, again, I see that 36 and 12, they're actually both divisible, well, by 12. So I'm going to divide 36 by 12. That's 3 and 1 equals x over 100. So just reducing the ratios to make my math easier. And 3 times 100 is 300. And 1 times x is x. So x is 300. So in this case, we saw a 300% increase. That's a lot of increase. And that's how we do these problems. Okay, now we're going to breathe and recognize that story problems are just like the problems we just did, only with words. So let's try this one together. We have 3 word problems here to try. A used bookstore buys a book for $5, then sells the book for 38% more than what they paid. What's the new price for the book? Okay, so how do we do this? So let's take a look at what we know. We know that they bought a book for $5. So the original was $5. Then they sold the book for 38% more. So increase of 38%, more than what they paid. What's the new price of the book? So I want to know the change. So they're asking me for, so this is, if I'm doing my guesswork here, this is my given. My unknown, they want to know what is the change. Okay, so let's go to our equations here. So I'm going to say, well, I know the percent. It's 38 over 100. Before we were solving for percent, so now I'm a little nervous, but I'm gonna go with it. I have the original, and looking at this, I know that it's supposed to be change over original. So I'm just going to say change over original. Oh, okay. Now it looks like something I could do. So I'm going to solve that, and I'm going to crisscross, and I'm going to say it's 38 times 5 equals 100x. Guess what? I don't know how to do 38 times 5. So I'm going to go over here and say 38 times 5. 8 times 5 is 40. 3 times 5 is 15, 16, 17, 18, 19. 190. So 190 equals 100x. All right, now let's get x by itself. So we're going to divide by 100. And that's great. When I divide by 100, I just move my decimal over twice, right? So 1, 2, bloop. So x, 1.9 equals x. Now here's the tricky part. That's just the change, which I spelled incorrectly. That's just the change. I like how I said it was chance. That's a nice one. So this is just the change. So what I need to do now is say, okay, my new price, because that's what they want to know, right? My new price is the original plus the change. So my new price is $5, right? Plus this change here, $1.90. So my new price is going to be $6.90 is the new price. And notice I'm writing it in a little sentence there. Boom. We did it. Okay, let's try another. Ricky took Sam out on a date. The meal cost $32.75. If sales tax is 5%, what's the total price of the meal? This is real life right here. Like we do this, I feel like you do this a lot in your real life. Is like, this is how much I have, what's it gonna cost? So what I'm gonna say is I have a percentage, right? So my given, I have a percentage, 5%. And I have the meal cost. So this is the original meal, cost $32.75. And I want to know the total price of the meal. So what I'm actually looking for again is the change and like total cost. Okay, so let's do an equation for that. So, okay, 5 over 100 because it's a percentage. So that's nice and easy. Then I have to sit there and be like, okay, so what is it on top? So if sales tax is 5%, so I know 5% and I don't know what this change is, right? This change here, I don't know what it is, but I know that the original is 32.95. So what X actually is, just for funsies, is X is your amount of tax, like how much you're going to pay in taxes. And 5% is exceptionally low. We pay this in Seattle. So, so there you go, just so you know. Okay, so let's do this. I'm going to crisscross. And I'm going to start with 100x because that's easy. And then I'm going to look at this and go, oh no, that's going to be a hard one. I better do this over here. 32.75 times 5. Oh, that's not as bad as I think it is. That's 5, 2, 35, 37. So 7, 3. That's 10, 13. 3. So then 15, 16. Okay, and I went 2 over, so I've got to go 2 over. Boom. So that equals 163.75. Okay, so I got to divide that by 10, or by 100 actually. That's not so bad. Now I'm just going to move the decimal over again. Boom, boom. So X equals 1.6375. Okay, now I'm talking about money here. Money only has 2 decimals, so it doesn't make sense for me to run all these decimals. So I'm actually just going to say 1.64 and round it. So looking at the 3, I'm going to round up because the 7 is the next number, so that should round it up. So it makes more sense for me to say 1.64. So that's my change only though, right? So my total cost is $32.75 plus 1.64. So I'm going to add those together, 9, 13, 4, 3. So the total cost after tax with an incredibly low tax, like I don't even know where these people live, is $34.39. So not so bad. All right, this one is going to make us think a little bit. So Brenda is buying her young son a tricycle, which is on sale for 20% off the original price. If the original price is $38.50, what is the discounted price of the trike? So if we're saying, so let's just go through the basics of this. We know that the discounted price is the original price minus whatever the discount was. Now we're told that the discount is 20% off the original price. So that's the original price minus 20%. Well, if the original price is 100% and I'm going to subtract 20%, I have 80 left, right? So what I'm really paying is the discounted price is really 80% of the original, because the discount is 20% off, right? So I could say it's the original price minus 20% of the original price, which is a lot of work, or I could just say, well, that's just 80% of the original price. And the way that we write 80% in decimal form is 0.80, or just 0.8. That's even easier. So basically, I want to know what's 80% of the original price. So I'm going to say 0.8, 38.50. And I get 30.80 if I do that math. Okay, so how can I do that math? Well, I did that math already, but I'm going to work it for you so that we can see how to do it. I would say it's 38.5, and I just went times 0.8. So how did I do this? I went 8 times 5 is 40. 8 times 8 is 64, plus 4 is 68. 3 times 8 is 24, plus 6 is 30. And then I went 1, 2 decimal over, so I'm going to go 1, 2. So that's how I got 30.8. And it's just 30.8, and I added the 0 again because it's dollars, right? So this is going to be the new price that she paid is 30.80. So that one was a little bit tricky to think about, that it's the original is like 100% of the price minus 20% is going to be 80%. But we did it. We got there. Woohoo! And then here is your homework that's due Thursday. Try the best you can, and we'll go over it on Thursday.